Okay, again, welcome to Shiny Happy Hour. So just to reiterate, this is a joint event between two groups. So who here is from Biodata Club? Just, you can say it in chat or you can wave your hand. Got one. I know we've got more than one. Yeah, so I've got like 4, so great. And then the rest of you are from PDXR? Okay, great. So like I said, this is I'm going to introduce Robin in a second, and she's going to be talking about Biodata Club. So Robin, would you like to talk about Biodata Club?
Yes, I would. Hi, everyone. My name is Robin Champeau, and I'm faculty in the OHSU library up on the hill. I'm also one of the co-organizers of Biodata Club, along with Mary Jane, who's on the call as well. If you don't know Biodata Club, we're an interdisciplinary co-learning community at OHSU. So we work with all OHSU community members and people outside of OHSU as well on data science learning and open science learning. And we really try to make it more accessible and also really sort of welcome a more diverse group of participants to that space. And I think I will also say that we are sponsored by the OHSU Library and the Department of Medical Informatics and Epidemiology as my little thanks to them as well.
Yeah, thanks, Robin. So for those of you who are in Biodata Club, we just want to introduce what the PDXR user group is. So if you're interested, you can learn a little more about us at pdxrlang.com. Those of you who don't know me, I'm Ted Laderas. So I actually, I used to be OHSU faculty. I have now moved on to a company named DNAnexus. But just want to mention that we're the R user group for Portland, Oregon. And our goals are very aligned with Biodata Club. We want to support learning and sharing experience and knowledge of R among the users in the Portland community. We have regularly scheduled monthly meetups. We're focusing on a meetup called Aggregate, where people can kind of come in with problems or things they want to show off and basically share them, and we can discuss them as a group. It's very intimate and it's pretty fun. So if you want to learn more about that, you can find information on the meetup page, which you can find from the pdxrlang.com link. We also have our Twitter at pdxrlang. So we do have 2 groups and they have 2 different codes of conduct. Just to make things simple, let's just follow the PDXR code of conduct. I'm going to post a link to this in chat. So if you want to take a look at it. So just to mention that we're dedicated to providing a harassment-free meetup experience for everyone, regardless of gender, gender identity, expression, sexual orientation, disability, physical appearance, body size, race, age, or religion. So we don't tolerate harassment of any participants of the meetup in any form. Sexual language and imagery is not appropriate for this meetup venue or any meetup venue, including talks. So any participants that are violating these rules may be sanctioned or expelled from meetup events at the discretion of the organizers. So if you have any violations that you want to report, please report them to Marley. This is his information here. I'm going to paste a link to, this is a link to this presentation, just in case you need that information. Okay, so who's speaking tonight? So I am Elliott Hohn. I hope I'm saying that correctly, Elliott. He's an analyst at the Freshwater Trust, Marley Buchman, and Kelly O'Brien. So just to make things easy, I'm just going to start off. And this is my topic. So who here has heard of Shiny modules? Kelly? Yeah, we've got a few. So I'm just going to kind of talk about, I'm not going to show you too much about how to use them. I'm going to talk about why you might use them. And I think this is something that a lot of people, they see this and they're like, I don't know what these are for. So I just wanted to kind of give you a use case so you can kind of understand what the reasoning for this kind of system in Shiny is. Okay, so I'm just, like I said, I'm just going to start out with a motivating example, and then I'll talk about a little bit more about why or why not to use modules, and then we'll end up with a little bit of like kind of a tour of how to write module code. There's also a accompanying GitHub repo. I'll post that link. And if you want to follow along, I am posting the slides into chat here. So, okay, so I just wanted to kind of start out with like a motivating example. So say you have basically, you have basically this kind of a Shiny app, and you want to produce histograms from columns in that Shiny app. But you have multiple data sets you want to do this for, and you want to have different kind of mini apps within the same app. Is that clear? Hopefully the next slide will make things a little more clear. So this is, one of the most, well, I'm not going to say it's one of the most boring, but I've seen it to death, but so sorry. This is the mtcars data set. And you can see that these are the column names within the mtcars data sets. And it just lets you choose the column and generate a histogram from it. Everyone clear on that? Any questions? Okay. So like I said, I'm just going to show you kind of how you set things up with Shiny modules, and then I'll kind of talk about these functions a little bit later. But instead of putting like your UI elements directly within your Fluid page, and this is just a very, very bare bones app. There's no layouts or anything. But you can see I have this select underscore hist UI, and this is a function, and we're passing it in this ID argument called mtcars module. There is another thing that we're just passing in a vector of the column names. So I've just labeled that mtcars var choices. But one of the most important things is this ID. So we can basically set this up, and basically it will set up our UI. And if there are any questions, please interrupt me, or please put them in chat. I'll try to pay attention as much as I can. So this is kind of our UI portion. This is the server side function. So I've made kind of this function that's called select underscore hist underscore server. And it also takes an ID argument. And you can see that our ID that we're passing in it is the same as the one for select hist UI. So this is one of the most important things about Shiny modules, is that you always have to pass an ID. And this is how, when you have multiple versions of the same module, how the different kind of versions of the UI and server these server functions know who they connect. Is that clear, or are there any questions at this point?
There is, Ted, there's a question in the chat that, is this being recorded?
Yes, this is being recorded. So.
Yeah, and Ted, I'm happy to monitor chat for you.
Oh, that would be great. Thanks, Robin.
Yeah.
So my main point being is that we've got these two functions, and we can just basically put them in our UI and our server, and they need to be connected by an ID. So when you do that, basically you can produce this this Shiny app. What if we wanted multiple versions of that plot, but with different modules? So this is just on the UI side. And you can see I just put another instance of that select_hist_UI function, but I'm passing it a different ID. So this ID is called Penguin module. The arguments that we're passing into it are different. This is called Penguin choices. You can see the previous one was called MT cars var choices. So these are just column names that we're passing. So to connect the second UI instance, we need to add another server select_hist server function. And so to connect this instance to this instance, their IDs need to be the same. So you can see that the ID here is Penguin module, and what is the ID for the previous instance?
MT cars.
Yes, exactly, MT cars module. So again, this lets us basically have two versions of the same UI and server app in the same these are modules, sorry, the UI module and the server module. So we've got two different instantiations of them, but they're differentiated by this ID and also the data that we're passing into them. So you can see that this one we're passing in the MT cars data, this one we're passing in the Penguins data. And yes, so there is a question, would you please share a link to watch later? Yes, I will have that. We'll put that up on the meetup page, so there'll be a link. So if you do that, basically it lets you have two versions of that same module. So this, on the left side, we've got the MT cars dataset module, and we've got on the right, we've got the Penguins module. So if you've done any Shiny programming, you know that you can't directly cut and paste things because the IDs for everything have to be unique. And so the module code actually lets you kind of make all of the IDs unique. Are there any questions about this? And I have plenty of time, so happy to answer any questions or any clarifications. Also glad, this is something I'm a little self-taught on, and I went and reviewed what Hadley wrote about this, and I think most of this is correct. But most people can see that this basically lets you reuse your code, right? So let's kind of talk about some reasons to use Shiny modules. So a lot of the times, like the example I just showed you was like, if you want to reuse your code, and especially if you want to reuse the code in the same app, it lets you kind of do that. The other thing, if you want to break up a monolithic Shiny application into smaller pieces, it's really helpful. And one nice thing about kind of breaking this up into smaller pieces is that it's easier to kind of test these individual pieces rather than like, you know, testing the whole Shiny application every time. And then, like I said, you know, it's one of the headaches when you're making these really large Shiny applications is making up unique IDs for all of the elements in your app, especially if they're kind of repeating. So making sure that all of those IDs are unique. So Shiny modules kind of automatically handles this, which is really nice. One thing that I'm just kind of going to put here, not going to explain too much, is it helps you kind of separate presentation from code. And this is a very good kind of practice. Using Shiny modules with something like Flex Dashboard will make your code a lot easier to read and debug. So any questions about this? Oh, thanks for the comment, Robin. So Robin said, as a newbie, that was really clear to me. So there's also kind of the inverse side, maybe not. So when you're kind of starting out and you're making kind of smaller apps, and you're just kind of making like, you know, really small apps, and you don't think you're going to kind of extend the code, you know, it might not be worth your time to kind of spend all of this time modularizing code, or that your app doesn't have that many controls or plots. So it is another level of abstraction, and we'll talk more about kind of how you kind of put modules together. So sometimes when you're getting started, I would say don't worry too much about like working with modules, but as you're kind of making going further in your career, you'll find that they're really useful. Any questions? If not, I'm just going to go over a little bit about kind of how you write the modules. So I didn't really have time to kind of completely unpack this, but I'm just going to kind of talk through this. And if there are any questions, please let me know. So this is the code for the UI module. And like we saw before, select_hist_UI is a function, and it takes 2 arguments. So the first is the ID, and the second one is var choices. So this is just our vector of column names that we want to select. So, and this is important, both the UI and server modules need this ID argument. So to use that, you need to basically instantiate what's called the namespace using this capital NS function, and the only argument it takes is ID. And this returns another function, and we're going to be calling that function NS. So if you're familiar with Shiny programming, this is where you put your unique ID for things. But instead of just putting, you know, a string with the name of with the ID, you need to wrap it up in this NS function. And this NS function kind of handles making like the IDs unique. And we can kind of talk more about that. But so anytime you have an ID, and here we've got a plot output here, we need to wrap it in that the ID in this NS function. Any questions about this? Because it took me a while to kind of get this. It wasn't exactly clear when I first got it.
So the modules are like functions that it's kind of like if you were doing just regular programming in R and you were writing a function because you were tired of writing the same code over and over again. Is that correct?
Yeah, that's a good way to put it. So like they're also great because they let you reuse code. So you might, you might be making like this very common thing that you're going to be using in a bunch of apps. And so it lets you basically reuse that code in other apps. That's a really good way to express it. Thanks. Any other questions?
So Ted, what will NSX_var return? Is that
so
just it?
What it does? Last time I checked, and Kelly, if you know more, you can you can correct me. So what it actually does is it appends the ID to the front of the var or this ID. So it basically prepends this ID that you're passing in to this string here. So if my ID was empty cars ID, what this actually becomes is empty cars -x_var. So that was how they were implemented the last time I checked. I am not sure if anything has changed, but that's kind of what happens is it basically kind of renames the IDs so they're unique. Does that make sense?
Yeah, and so that means that you have to give it a list of variables with the data set that you're aiming at.
Yeah. So in this case, I've just basically added this argument called var_choices. And this is a character vector of the column names that we want to select. And you can see that this gets passed into the select input here as the choices argument.
Okay.
So there's other ways to do this. When I finished doing this, I figured there's a better way to do this by just passing in the data and just doing some intelligent processing. But I just wanted to make things as simple as possible for this example. Good question. Anyone have any other questions? Okay, so the last slide I'm just going to talk about is the server module. The first thing I want you to notice is that this, everything that's highlighted in yellow here, this is just like any other writing and output. And this is just basically making our histogram here. And it's being assigned into output $hist plot. So this is just like normal server code, but within our function, you need to wrap it up in this module server function. And this is a bit of a mind bender because you're passing in the ID to this, but you're also passing in a function, and the function is your server code. So one thing I will just say is just be really careful with your closing curly brackets and parentheses. I make this mistake all the time when setting up modules, but that's kind of the basics. So I'm going to paste this link into chat again, so you can kind of experiment with modules. Do people want me to see me demonstrate this, or should we just move on?
I might be down to see it, yeah.
Okay, so I've got RStudio set up here. So this, is this big enough, or do you want me to make it bigger? I'll make it bigger.
Yeah,
thanks, Ted. Bigger. Yeah.
The answer is always it should be bigger. So this is an RStudio project. So if you download the repository, you just need to open up the shiny_module_tutorial.rproj file to open the project. And so this is exactly the code that I was talking about. So in modules.r, this is that code that I was just showing you for the select hist UI and select hist server function. So you can kind of take a look at that. And this is just this is the code that just uses the single module. So I'll just run it. And you can see it does that. we can change our select variable and display a different variable. So there is also another one if you go back up into module_demo_2. So this is the app that has the 2 data sets. So you can see that this is the same code that we were talking about, and I'll run that app. And you can see that we've got our 2 different data sets. So this is our MT cars data set, and this is our penguins data set. So they're completely independent of each other. So you don't have to worry about any kind of interactions or anything. So that's all I have. So Elliott said he had to go in a little bit. So does everyone else mind if Elliott goes next?
Sounds good.
Okay. So you should have the power to share, Elliott. So please go ahead.
Oh, thanks, Ted. Let's see. All right. Ted, that was awesome. Thank you for that presentation. That's a really interesting topic.
My pleasure.
Cool. Well, thanks everyone. It's nice to see you all. So I'm going to talk about some recent kind of exploration I've been doing around kind of how to make plots and tables and maps interact with each other within a Shiny app. So thinking about a lot of the JavaScript libraries that that you can interact with through various R packages, things like Plotly and Leaflet, data table, a variety of others. I'm going to talk a little bit about some stuff that I've been trying to learn around how you can connect those different components within an app so that you can interact with a plot simultaneously interacting with an adjacent table or map. So kind of like how Ted started his presentation, I want to talk a little bit about kind of the inspiration for this. So as Ted said, I work at the Freshwater Trust, which is a freshwater restoration and conservation organization. We're a nonprofit based in Portland. We do a lot of kind of data analysis and various types of analytical work around our projects. And one of the things that we've been doing a lot of recently is building Shiny apps, dashboards, and other types of interactive tools that we can use to communicate with our clients and help kind of share some of the environmental modeling and economic modeling work that we do in a way that is kind of interesting and intuitive to our clients. So this is a screenshot of one of the Shiny apps that we built recently, and this was one of the things that kind of inspired me to try to learn more about how to make these different components interact, because you can see we have a map in the bottom right corner, so that's a leaflet map. On the top here, we have just some static ggplot jitter plots. And then the bottom left, there's a DT data table. And those all contain information that are related to one another. So each of those dots on these jitter plots is representing one of the field polygons in this map, which is also representing one of the rows in this table. And I was struggling really hard to figure out how to allow the user to explore this data in a way that was intuitive, where you could click on a field and that field would interact with would highlight one of the points on the plot and would also show up on the table so that you knew kind of how those three components were connected to one another. Ultimately, I ran out of time on that project to get that figured out. So it's still just static ggplots on top and the two other components that are not actually connected. So I thought that figuring out how to do this would be really useful. So while kind of looking into that, I found just tons of great resources on how to interact with some of these different libraries, JavaScript libraries within R. So you're all probably familiar with Plotly and how easy it is to convert a ggplot, a static ggplot, into an interactive Plotly plot. There's some great D3 wrappers that you can use, Mapbox, Leaflet, React tables, a variety of different things. So I can share some of these resources in the chat in a minute, but there's some really great free books online. So I kind of started going through those and seeing how I could play around with that. I'm sorry that the formatting of this is kind of bad. This is the first time I've ever used R to create presentation slides, so my apologies. But on the right side, that's actually just 4 lines of code that is creating a really simple interactive Plotly histogram, or set of histograms. So super simple to create these, and have different ways to interact with these plots. And when you start getting really complex plots with thousands of points, it's really nice to be able to zoom in on those points and check out all of the kind of detailed information. So what I wanted to do for this talk was I put together a Shiny app that attempts to use do two different things that are kind of related to this topic of interactive widgets, and kind of using JavaScript functionality to allow these pieces to talk to one another. So the first part of it is using this really great R package called Crosstalk, which is a way of creating a shared data environment between these widgets. And what it does is it basically it tells R that you have this data source that can be shared between these plotting and mapping and data table functions, and it allows them to kind of communicate with one another. Its functionality is kind of limited, as you will probably see in a second, but it's a really cool really easy way to interact with these components. So I'm going to use that to build a Plotly, just a really simple scatter plot in Plotly, and then a React table, and have those two pieces kind of talk to one another in a way that allows you to select a set of points in that plot and have those show up or get filtered automatically within the table. And then HTML widgets, another R package, which is super powerful and a really, really fun thing to play around with. So I'm going to use that with a really simple JavaScript function to create some buttons within the data table that can allow you to zoom in on polygons within a leaflet map. So I will open that now. And I just finished this app like 2 minutes before the talk. So let's hope that it works. And I'm not monitoring the chat. So if people, if anybody sees a question, feel free to jump in and interrupt me.
Yeah, we'll let you know.
Okay, thank you. Okay, so this is using the Tidy Tuesday data set from this week. So it's a data set on broadband access across the US. So it has information on zip code level, usage of broadband, and then I just pulled in some census data to attach a few other variables to the zip code level data set. So at the top here, we have a leaflet map. The polygons are zip codes. This is just the state of Oregon. And so for each of these, you see it has a percentage broadband usage across the entire zip code. In the bottom right, we have a Plotly plot. So it's kind of getting cut off here. Let's see. So the x-axis is median household income. Y-axis is broadband usage percentage. So just kind of showing that as the median household income within a zip code increases, on average, you're having more people accessing Wi-Fi. The size of these points is relative to the population of those. So you'll see a lot of these really small, kind of poorer rural counties don't have great broadband access, which is not super surprising. And then on the left here, this is actually cutting off the, let me see if I can open this. Okay, this might be better. Okay, so on the bottom left here, this is a React table, which is another library that folks should check out if they're interested in some really kind of powerful table creating functionality. You can do some really, really cool stuff with React table, and I'm kind of just starting to learn it, but it seems like a really great tool. So this is a React table. And so yeah, so what I have set up here is the plotly plot in the bottom right corner will communicate with the React table by allowing you to, for example, select a point, and that point should, oh, I may have broke something. There we go. So that point that was selected happened to be Clackamas, a zip code within Clackamas County. So that shows you where that point is on that plot, and then the HTML widgets functionality was used to create this action button, and that action button should zoom to that county and allow you to figure out where that is within the state.
Cool.
So those are kind of the two little fun connection points, and then I can, would folks be interested in taking a look at the code that was used to generate this? Or maybe I'll pause and see if people have questions before I get into the code.
Any questions for Elliott?
How long did you spend ironing this whole thing out? Like, how long did it take you, I guess?
Good question. Probably, I'd say probably like 5 hours.
Wow, that's like way faster than I thought it was gonna be.
Well, I should say that, I mean, some of these pieces I've pulled out of work that I've done for the Freshwater Trust for other Shiny apps. So things like this button, just creating a unique button ID for every row in like 1,000 row table was a very complicated thing to figure out how to do, because Shiny is not, Shiny requires a unique button ID for, so if you click on a button, if that button doesn't have a unique ID, then it will basically act on every button that has that same ID. And so when you have kind of a changing, a table with, a dynamic table with a changing number of rows, creating a unique button ID for each of those without doing something that is either extremely tedious or just kind of bad practices in terms of like writing big sloppy loops was super challenging. And I ended up poaching some really great code off of Stack Overflow to help me figure that out. But that piece alone probably took me 15 hours. So I should preface my 5 hours by saying this is built on a lot of learning that was done previously.
Mm.
Are you okay with sharing your code, Elliott?
Yeah, absolutely. And I will push this to GitHub, and I can share the link to the repo a little bit later.
That would be great.
Yeah.
We'll put the link to the repository on the meetup page, and I will paste a link to that for Biodata Club people in a second.
Cool. So I have this app set up in multiple files. I'm just used to building apps in multiple files because a lot of the stuff that I've done previously gets pretty complex. So I have it set up with a global.r file that creates kind of the it does all the stuff that's outside of reactivity within Shiny. So things like building color palettes and creating like labels for the pop-ups and things like that. So that all lives in the global.r, and then I have separate UI and server files. So the UI code for this is super simple because all it is just three different sections there, the big map on top, and then the plot and the table on the bottom. So there's nothing very, very special in the UI. And then in the server, I think that probably the most important part here that is unique to kind of this topic is this line right here. So shared data this is how you mark a data frame as being kind of this shared asset that can be passed between different components of your server code. So this BBSP is the spatial, it's a SP object that has the polygons for all the zip codes. And so that if you end up looking at my code in the repo, you'll see there's this dataprep.r file. And this is where I pull in the Tidy Tuesday data and then kind of do all the cleaning and processing of it. So, and then I just save that as an R data file and pull that into the Shiny app in the server.r file. So there's a spatial version of that data set, and then a non-spatial versions for the table and the plots. So starting with that spatial data frame, all you have to do is you add this line that is shared data $new, and then you just give it a group name. And anything else that has this line in it, any other data set or any other component within your server code that has this line and groups it as this same name will be able to communicate with one another. So this is the map component. And then if you go down to the table, for example, I did the same thing here with the table, just added it to this group, and that allows those two things to communicate. And then the plot as well, shared data, new, put it in that same group. That way you have each of those components is using, it might be a slightly different instance of that data set, but but they're all shareable and can communicate with one another. So if you filter one, you're filtering the other. Does that make sense for that part of it? Does anybody have any questions about this? Sorry, yeah, go ahead.
Yeah, so Ian is asking, so the boxes on the top of the table are for searching or filtering. Wondering if entering an address to get the zip code is hard to do.
Oh, entering like a street address?
Right, that's right. And that's something I've tried to do with Shiny. And I can almost make it work, but the problem is that I can't make it wait until I've entered the entire text string. So I get, Iceland shows up and Burma shows up, but eventually I enter the address and then I get to the place in Oregon that I want.
Ian, the problem that you're trying to solve is the thing that I'll be talking about just whenever next.
Outstanding. That's great.
Sweet. That's perfect. And so I should mention that this function here, this key thing that I'm talking about, this is part of the crosstalk library or package.
Yeah, nice.
And then the last thing I'll show, and then I'll pass it off, is the way that those zoom buttons were generated. It was actually easier in the React table package than other ways that I had tried it before. But basically, what you do is you add an empty column into your data frame, and then it's this simple JavaScript function, basically, which kind of creates an ID for each of those, and then it sets an input value for when you click a field, it communicates that field that you've clicked on, or that row in the data table. It communicates that information back to Shiny, and then I just created this observe event. So anytime this clicked field, one of those clicked field buttons was clicked, then it finds that zip code from that row, and then it just filters the spatial data set by that zip code, and then just uses leaflet proxy to add kind of a new highlight polygon on top of that, and then zoom to that polygon.
That's really cool.
Wow.
Cool. Any other questions for Elliott?
Elliott, this is Joe here. I had a quick question. You said that crosstalk was kind of limited between maybe some tables and then some Plotly stuff. I wanted to know, is there anything for network diagrams, do you know, that would then communicate between like a table or other things, or do you think that's just not there yet, or is something that would need to be custom done?
I think that actually does exist. So I forget which JavaScript visualization library it is, but there are a few of them that have some really great network diagram options. And my understanding is that pretty much any of those JavaScript libraries, most of which have some sort of R wrapper, can be used with crosstalk.
Yep. If there's an HTML widget for it, then that makes it really fairly easy. And we're not going to say it's going to be super easy because there's always challenges, but it makes it simpler.
All right, nice. Well, thank you.
Cool. Thank you so much, Elliott.
Yeah, thank you all. I'll stop sharing now and pass it off. Thanks, everyone.
So, Kelly, is it okay if Marley goes next, just to kind of build on what we just talked about?
Yeah, of course. And then I'll close it out.
Awesome.
Perfect. Yeah.
So please go ahead, Marley.
Okay. All right, so couldn't have done a better kind of preface to this than what Ian asked just a couple of minutes ago. But basically, I'll just run this very quickly and show what the app looks like. But I work as an economist for a local consulting group, and I do a lot of spatial data analysis. And I work a lot with census tracts or block groups, which are basically just census areas that are smaller than a city. And a big issue is that regular people don't really know about census tracts. And so if you are showing like an interactive map like this, and it's just median household income in 2019, people might be interested to look at like, where do I live? Like, what's the median household income in my neighborhood? But you can see that these like borders aren't particularly like informative. So you want to have this kind of search functionality. And this is very similar to what we just saw, and being able to kind of have one part of the Shiny app talk to another on the UI. But a big problem, and the reason I wanted to kind of give this very quick talk is that this took me forever to figure out. But we have right here, this is like the little placeholder text, and this is my office that I used to go into work and where we used to do aggregate. But you would start typing it and it would try to zoom the map to the location after every character press. And so I needed to figure out a way to basically avoid that from happening, so that you could, again, put in an address. Can't really type. And then I have this set up where you would actually hit enter and then kind of zoom in to the neighborhood. So I just put this like little toy app together for this talk. So like I thought the best thing would be to kind of just walk through the code, given that it's pretty simple, and that the app's really like, there's nothing to the actual like product here, is just to kind of showcase this functionality. So I've in a previous kind of meetup for this group, I've talked about tidy
Marley,
senses.
can you make it a little bigger?
Oh, for sure.
I know there are about eight people who will say that. So.
Okay, yeah, no problem. So in a previous talk, I've pitched tidy census before, which I use daily for my job, and I think is by far my favorite R package. And if you're at all interested in working with like data from the census, it's really like absolutely wonderful. So I have a bunch of different libraries here, mostly in the tidyverse, plus some spatial stuff, including this ggmap that I'll get to, and HTML tools. But this is just the variable name from the census for median household income. And this function getACS is essentially a wrapper around the census API. So I'm saying I want to get tracked as the geography I'm interested in. I want to get basically this variable for 2019. I'm just caching the results so it's a little quicker. For Oregon, Multnomah County. And then all you have to do is say geometry equals true, and you'll get a SF object back instead of Tibble. So it's very quick to get spatial data. And I'm just renaming the census variable estimate to be median household income. And then you don't even have to do this, but just to get rid of an error message, I'm changing the projection to kind of fit what leaflet does. So that's everything to get the data. And then I just make a function to make my map. And so this is just the color palette to do it by blues. And then when we hover, or click, we want to have a little pop-up that just has the dollar value. I'm definitely going like very quick, but if you've made like a leaflet map before, this is all pretty like straightforward, and almost all of these kind of parameters here are just control the different like aesthetics of the map. And I have, again, I'm just basically, this is saying like, use the palette on this value. And similarly, we're using the HTML function from HTML tools that's gonna basically read this as HTML. And that's how we get our hover. So, and if you notice, this is when the address is equal to blank. And so I just have another kind of conditional here, which is saying, well, what if somebody entered in an address? And then if you're unfamiliar with what geocoding is, this is basically not just in R, this is like in general, kind of within like spatial or GIS, I should say, is that you have some sort of address and you want to get back the coordinates of that address. And so there are certain free services that you can use, and I think you can even do it through ggmap. Luckily, like for work, we do this so often that we have like an account and we pay Google, and it's like you get like 50,000 free or something like that. But to use the Google one, you do have to have like a credit card attached to your account and the API key. But essentially, all this function does is I would pass in an address. And then this geocoded address is just going to be a tibble with 2 columns for the longitude and the latitude. And so the only thing different with this map code here is just this set view, where I'm saying basically like zoom in at this longitude, so the geocoded longitude and the geocoded latitude at this level. So this is the only thing that changed in the code. But the really interesting part is like, well, so how do we get the address to kind of populate at the correct time for this function? So this does require a little bit of JavaScript, and I found this on Stack Overflow because it is way outside my wheelhouse. But essentially, like as I tried to like figure out what this is doing, is the key code right here, which looks incredibly cryptic, is equal to 13. This is just, I guess, mapping to the enter key. And so it's just trying to look for basically the pressing of the enter key. And you can see key pressed here. And then this was really confusing to me, but I guess you need to have some sort of like random assignment to it to avoid like collisions, or there's some sort of reason that like you can't just have it like iterate or whatnot. But this was not something that I did originally, but I'm happy to share this, Ian, if you're having this problem. But this was my solution, finding this kind of custom JavaScript here on Stack Overflow. So the UI is like very simple in that we just have a text input and then our kind of leaflet output here. And so this is where you enter your address, and that the placeholder just shows that kind of like translucent text in the background when there is no value. And so I have this like tags script here, and that's passing in this JavaScript code. So that's how we're kind of like ingesting and processing this kind of custom JavaScript here. And then on the server, this is where we need to use reactive value. And so I think this is really similar to what Elliott was kind of showing before, although we're kind of doing it maybe the old-fashioned way without that package that's able to kind of communicate between all the different things. But we're just kind of creating a reactive value, and it's just blank here. And we're assigning that to this reactive address. And then we have this observe event function, and these are Shiny functions. And so it just is input on key pressed, which is mapped again to this JavaScript code. That's where that's kind of coming into play. And then the reactive address is just taking the user address that's inputted on the app. And then we just pass this reactive address as a function to this address field, which is just my little silly function here that is looking for whether or not it's empty. And yeah, that took me absolutely forever to figure out, but now I kind of do this all the time. So happy to share, Ian, if that's helpful for you.
It's extremely helpful, and I think I owe you for this. Maybe a related question. There's this thing called a bounding box that I've tried to use with maps. Is there some way to make sure that a user can't just scroll out past Oregon into, any other place on the globe?
I do think that you can do that. I don't know how to do that on top of my head, but I think that that's actually all within leaflet and kind of the leaflet functionality, which in my opinion is like a little cumbersome to try to like navigate, because it is just a port of the JavaScript library. So it's not like, as somebody who doesn't have really any JavaScript expertise or background, it's a little bit unintuitive. But yeah, I do think that you can kind of control or like lock down basically your map frame and the different levels of zoom. But that's not something that I usually just kind of allow that behavior and hope for the best.
I think there's a function in leaflet called, I think it's called set map extent or set max extent maybe, but it's set max bounds, that's it, yeah. So you can use that to set kind of the maximum zoom.
Great, thanks, Elliott.
Yeah, that seems exactly, yeah.
Awesome. Thank you so much, Marley.
Yeah, are there any more questions or?
So where does this valuable intellectual property live? Is there?
I mean, I can just send this to you. This was again, I just made this for this talk, but I could put it on GitHub, or just it really is there's no data here. It's calling tidy census, so I could even just send you the code snippet if you want.
That would be lovely. Thank you.
Yep. Or if you could put it in a GitHub gist, that's an easy way to share it.
Yeah. See, I mean, the whole thing together is easier to grasp and parse than just the limited chunk, in my opinion. So yeah, I'm voting for the whole app.
Okay.
Awesome. Well, so last but definitely not least is Kelly O'Brien. Are you ready to present, Kelly?
Yeah.
Okay, so take it away.
Cool. So I wanted to start with a PSA about the Mastering Shiny book that Hadley has released last year. It's freely available online. You can just go to mastering-shiny.org and read the whole thing at your leisure. There's a chapter on Shiny modules, like Ted was talking about. And Hadley does a great job explaining all these Shiny concepts. I helped in a very, very small way towards the back end of this book on best practices for Shiny in production, because my job at RStudio is on the RStudio Connect team. I'm the product manager for Connect. So I'm going to talk about chapter 11, bookmarking, because it's one of my favorite things to experiment with these days, in addition to something that's not covered in the book, but I think is really cool, which is also has to do with packaging some JavaScript code into Shiny by way of a service called Hypothesis for annotations and commenting. So the combination of bookmarking and commenting in Shiny applications, I think is really powerful and interesting, because I do a lot of this. I like to connect with users as I'm building out Shiny applications. So connect with collaborators, connect with like tester groups, and connect with end users. And my application can live in different places at different times of its life cycle. And I could be collaborating with different groups of people and need to do that in a way that I can have stream of consciousness conversations, much like I were iterating on a Google Doc or something, where commenting is a really powerful tool. Now, the problem with Shiny applications is that they sort of have this stateless being. So in a normal Shiny application, you go to the application wherever you're hosting it, and hopefully it's a place where your collaborators or end users can also access that application. It's not just running locally on multiple different machines, but unless you have bookmarking enabled by default, that stateless functionality of Shiny means that they have to describe to you the sets of inputs that they have entered into the app in order to get to a certain state. So it's very hard to, like, out of the box without bookmarking, replicate the state that another user is seeing in another place at a given time, if that makes any sense. So that's why I like bookmarking. But even with bookmarking, where you get a URL of some sort that allows you to replicate that state of another application somewhere else that someone else is seeing or has produced, you are still passing around like individual URLs and trying to keep track of them and have conversation out of band about those different states of your app and debugging it, etc. So combining it with a tool like Hypothesis, which I'll show, is really interesting and powerful, because it lets you have conversations inside the app itself. So this is not an RStudio product at all. It's an open source product called web.hypothesis. And it allows you to add this JavaScript plugin to anywhere on the web so that you can chat about and annotate on web-based content. So this is kind of how it works. You just have to select some text, can annotate it on the side of your browser. You can have multiple accounts, so your collaborators can create accounts and reply and share notes about web-based content. You can annotate together with groups. You can create different groups or chat publicly. And then you can also do search within notes you take on public annotations. So it's pretty nifty. To get started, you just have to go to add it to your website, and it'll give you instructions for embedding this JavaScript snippet. So this is the only thing that I'll be embedding into the Shiny application today, actually two things. So this first line where I grab the Hypothesis JavaScript code, and then the good habits line down here where I'll create a canonical link, so that if I have, like within RStudio Connect, multiple pages that represent the same application, I can keep that same block of comments together within those multiple pages. So these two things, and in order to do that, I've created this gist that sets up bookmarking because it's a little bit different of a Shiny framework, then adds the JavaScript, and then adds one more little piece that I like to add as well. So I'll talk about that too. So first for the bookmarking, actually I'll swap over to my RStudio here. I've added just the Shiny library and a library called GetLink, which is a bonus here that I'll show that my friend Cole made. So this is a crayon package that allows you to add like a little ribbon on the side of your app that says fork me or follow this link to the code. And I just think that those are nice and good practice to add when you're sharing code, especially apps around places and people want to navigate back to see your code. So this is this first line, ribbon _ CSS, and it just says link to the code, and that just adds the little ribbon on the side of my app. Now, the first thing you do to set up bookmarking for an application is to turn your UI into a function. So all you have to do is create a function called UI and have it input request, and then wrap everything, your fluid page. This is just the standard Old Faithful Geyser application. So I put all of that into this UI function. The second thing that you do is add session to your server. And then you enable bookmarking down at the bottom. So there are two different types of bookmarking, URL bookmarking and server-side bookmarking. The URL bookmarking adds your input variables to the actual URL, and server saves that out to an RDS file on the server. The thing to note between the two is like you can save much richer state if you're using server-side bookmarking, but that is not enabled on shinyapps.io today. So if you're using Shiny Apps, you have to go with URL bookmarking. There are two other pieces that you'll notice got added to the server. So there's an observe event. It's looking to pull in every change in the input and run session do bookmark. And then it will, on bookmarked, update the query string in the URL. So that's all there is for bookmarking, just like basic concepts. You can do other things like create a button that enables bookmarking, and I can show an example of that as well, but this is sort of what I use as the framework for myself to get started when I'm adding these two components to any app as a getting started guide. So the other two pieces that are added to the standard app here are the JavaScript coming from Hypothesis and that canonical link reference that I mentioned. So this canonical link, I actually don't know until I've published my application for the first time. So until publishing, I have to kind of leave this commented out and then publish it again if I want canonical links. This piece is really simple. You'll see this is the same exact script code that came from the Hypothesis website. And then I just wrapped it in tags, head, and HTML, which are really nice little helper functions that you get from Shiny. So that's all there is to it. I'll show you the app that's running on Connect.
Oh, Kelly, there's a quick question from John. So what's a canonical link again?
So I'll show you what that, it's easier to show on Connect actually. Let me go there. So here's what the app looks like. And then here's what the Hypothesis framework looks like. So to start annotating, you can log in, say log in, and then you can start creating little notes. And again, using bookmarking, because it happens automatically, I can grab this link and I can say, hey, I think I found a bug, and then turn a bug into a link. So there, now all my collaborators who come to this view of the app can see it here. Unfortunately, because I don't have that canonical linking turned on, if I view this app via the Connect dashboard, so if I come over back, if I do some link hacking and I go back to Connect here and I find my app inside of the dashboard view, you'll see that my same note didn't come over. So that's what the canonical link does. Once I turn that canonical link on to a vanity URL, so save that, and then copy it, go back to Connect, cancel, update it here, and then save, and me republish to Connect. Oh wait, I didn't uncomment it. That'll be problematic. So I need to publish again. But once I did that, then I would be able to, no matter which format of this app I went to, it would be using this vanity content URL that I set up for the application itself, so I could see the same comments here in the dashboard as I did for the open solo view back here. So that's just an important step, and it's kind of like a safety quality of life thing that you need to keep in mind when you're creating web-based content that can be viewed in different forms or different pages.
That is awesome. It's really awesome that you can kind of, you can get like be able to kind of bookmark and, you know, get feedback and all of that using.
Yeah. That's super cool. And another cool thing about Hypothesis is that it can be, I think, it either configured or it automatically dumps. I think you do have to do one configuration thing to turn on an RSS feed for all of your comments. And then you can use just the basic /feed inside of a Slack channel or something to follow an RSS feed. So what I have hooked up for this particular server is that all the Hypothesis comments that come through on any application that exists on this server all get dumped into a particular Slack channel. So we get to watch everybody interact with different apps and ask questions. And I think it deserves a little bit better of an integration, because it won't let you like @ people on Slack through the RSS feed. And that would be really cool if you could do that. But you know, it's pretty great for what you get for free.
Yeah, I mean, Hypothesis is just a really cool utility, and I've seen people do some really neat things with this, but this is just a different use that I've never even thought about. So it's really cool. Any other questions for Kelly?
I'll show you one more complex combination of these, since that was just the basic. I have a bunch of bookmarkable state apps here. This one's still a toy example, but this one is multiple tabs. So, and this one does server-side bookmarking. So you have to click this button if you want the bookmark, but then you get a state ID URL, and you can copy that. And again, use the annotations and the page notes. This one has actual text on it, so you can do annotation, and you can do highlighting or annotate. You can say, what's this? And Slack is blowing up with all of the comments that I Cool, so that's all I had. This is my new favorite pattern, combining these two tools inside of applications, especially during development. Hope this was interesting to some folks.
Yep, thank you so much, Kelly.
Yeah.
Well,
Fabulous.
That's it. I think we've people have signed off, but anyway, I just want to mention that there will be an aggregate. So sorry, Brittany isn't on. Does anyone remember? I thought it was May 26th. Just a sec. Yeah, May 26th, we'll have an aggregate again. So if you want to come in with any issues that you're working in or show off something, feel free. And thanks. I will get everybody's links and gists up on the meetup page, and I'll send a link to the OHSU folks so they can take a look at it too. So thank you, everyone. So hopefully this was interesting and an interesting learning experience for everyone. So any other things that people want to bring up before we say adieu?
Thanks for pulling it together, Ted.
Yeah.
Yeah, thank you.
Yes, thank you, Ted.
So I'll get the recording up on the meetup page as soon as I can as well. Okay, have a good night, everybody.
You too.
Bye.
Thanks, Ted.
Good night,
Bye,
Ted. Good
guys.
night, everyone.
Thank you.